Okay, so we're skipping 3.3. We're going into 3.4. So we're not doing anything with complex numbers. So we're going into 3.4. So remember, with lines, we start off with lines, we solve equations of lines, and then we solved inequalities of lines. Well, we're going to do the same thing with quadratics. We're going to solve quadratic inequalities. All right, so understand the basic concepts of a quadratic inequality, solve it with graphs, and symbolically, which symbolically will involve a table. All right, so inequalities are when we are less than, greater than, less than, or equal to, greater than, or equal to examples. Now, the first step is when we set up an inequality, always again, just like when we solve a quadratic, the first step is to set it equal to 0. Same thing's going to happen with the inequality. We're always going to put it to 0. So it's either going to be greater than 0, less than 0, or greater than or equal to 0, less than or equal to 0. We want to know positive parts of our quadratic, negative parts of our quadratic. Right, we want to find the boundaries. All right, where does the quadratic lie between? All right, all of the x values that make the inequality true. There are a few methods. We're going to look at the graphical method and then the algebraic, symbolically is what they call it in this book, method, which does involve a table. All right, we'll start with the graphical and then we'll do the algebraic. Before we get started, though, we're going to understand what types of answers that we can get. The very first thing you do is you find the zeros. That's why we practice finding zeros. Whether it's either method, the very first thing you always do is set the inequality to 0. So always make sure that it's a less than, greater than 0. So we want to always get it in the form, our quadratic greater than or equal to 0, our quadratic less than or equal to 0, or the strict case where it's greater than 0, less than 0. Alright, so always do that first. So sometimes you have to rearrange the quadratic in order to get that. And then we're going to use the zeros. Alright, one of our methods from 3.2, we're going to find the zeros. So you're going to find when the quadratic was equal to 0. Find its zeros using any of the methods. Alright, what are the x values where our function crosses the x-axis? Remember, you can get one solution, two solutions, or no solutions. You can use any of the methods that we talked about in 3.2. Graphical method, factoring method, or the quadratic formula method. We will start off graphically at first, so we'll do the graphical method first. So before we get into that, though, there's some important things that you should, again, know about solving graphically. So again, graph the function, so we'll graph our quadratic. Find the zeros, right? Always start with finding the zeros where it crosses the x-axis, and you can do that graphically. And then what you're looking for is when is the graph positive and when is the graph negative. Right? When it's above the x-axis, it's positive. When it's below the x-axis, it's negative. Right? One of those should solve for your inequality, because if it's greater than 0, we want the positive part. If it's less than 0, we want the negative part, the below the axis part. And then if it's an equal to, you just include the zeros, right? If it's less than or equal to or greater than or equal to, it's those x values and including the endpoints, right? We use brackets on the endpoints. And so some possible solutions when we do solve some stuff graphically, there's basically three things that can happen. All right, you could have a graph where it crosses twice. Right, either that case where it opens up, or this case where it opens down. Alright, and so this would be 0, 1, that would be 0, 2, and same thing over here. And you'd find those graphically. And so what we mean by, this would be the positive side, alright? The tail here going from our 0 to infinity and negative infinity would be the positive piece. Between the zeros would be the negative portion. So depending on what my inequality is looking for, if I'm looking for my f of x greater than 0, well, that's the positive parts. That would be going from negative infinity to the first 0, or from my second 0 to positive infinity. If I wanted to know when this particular function was less than or equal to 0, well, that would be my negative. And this time I'm including 0, so I include my stopping points. So brackets at my zeros. So I'm between my zeros. And with the equal to means I include them. Right, something similar would be said for this case over here. It would just be the exact opposite, right? This case, my negatives would be the infinity case. Right, I'm below the x-axis going to my infinities. I'm above my x-axis between the zeros. All right, so that's one example where it hits it twice. Right, the other cases would be if it hits it once or none. And so I'm going to do the once case and then the none case. Alright, so suppose that I have a graph where I have 1, 0, right? And so the 0 is at the vertex. It can open up or it can open down. Right? But that 0 is my vertex. Alright, so if this one we're looking for, when is the function positive? Well, it's positive everywhere but at the 0. So whatever that 0 was, it'd be negative infinity to my 0. Or my 0 to infinity. If it was looking for when it was negative, well, the answer would be never. It's never negative. Now, if it was equal to, if it was positive and equal to, then it would be all real numbers. So if we included the 0, it would be all real numbers. We didn't in this case, so it didn't include the 0, so we don't include it there. And this would be the exact opposite. My function f of x is never positive. And if I wanted to know where it was negative or 0, so I'm going to include the 0 in this one, it means it's always negative or 0 at the one spot, so that would be everywhere. Alright, so that would be the bouncing off case. Those would be the two cases. The last case would be if it doesn't cross, it has no zeros, right? We can have cases, two special cases, those are the last examples, where it never crosses the axes. Alright, so either the parabola is completely positive above, or it's completely negative below. And so in this first case, f of x is positive everywhere. F of x is negative never. Read that. Right, the opposite true for this case. F of x is never positive. F of x is always negative. And in both of these, there are no zeros. Zeros don't exist, right? Never crosses the x-axis. And so those are the possible solutions that we can get when we solve quadratic inequality cases. And that's what we're going to do. We're going to practice a few quadratic cases in the next video. Solving them graphically.